We are solving a problem in AC current. It says a 40 volt capacitor is connected to an AC source. So there is a capacitor C connected to an AC source. That's what is being given in the problem. The RMS value of the current in the circuit is how much, right? So first of all, when a capacitor is connected to an AC circuit, opposition to flow of current by capacitor is called capacitive reactance. Capacitive reactance. We can find that capacitive reactance as XC equal to 1 by omega C, where omega can be written like 2 pi into frequency and C. Now we know all the values. Let us substitute all of them and get the value of XC. 1 by 2 pi. Frequency is given in the problem as 50 Hz. Capacitance is given as 40 micro. Micro means it becomes 10 power minus 6. So this minus 6 in the numerator becomes 10 power plus 6. 2 into 5 is 10, and there are 2 more zeros are there. 2 into 5 is 10, and of course okay, or else 2 into 50 is 100 into 40, and pi is there. So there are 3 zeros, this can be cancelled, it becomes 10 power 3. So the value is 10 power 3 means 1000 by 4 pi. 1000 by 4 is 250. So the capacitive reactance of the problem is 250 divided by pi. Now you know the capacitive reactance. The value of the voltage is given for you as 200 volts. As it is not mentioned as V maximum, generally what's the value they give is an RMS value. We can call it like a VRMS. Then we can write a formula VRMS equal to IRMS into opposition to the flow of current, that is XC. So VRMS is 200, IRMS I am supposed to find out, XC we have found it as 250 divided by pi. That implies IRMS is 200 into pi by 250, that is 4 by 5 times of pi. You know 4 by 5 is 0.8 times of pi. You know pi is 3.414. So it is less than 3.414. So its value is 2.5 amperes. So the RMS current is 2.5 amperes. That's how I have to solve this problem. That's it. It is just a formula based problem. Knowing the formula will help you to solve the problem easily. Thank you for watching. Let us solve another simple problem that was given in NEET 2019. It says a circuit when connected to an AC source of 12 volts gives a current of 0.2 amperes. So the voltage given in case 1, that is in AC, as voltage is 12 volts, current is 0.2 amperes. So using the formula V equal to I into impedance, because it's an LC circuit, we call that opposition to the flow of the current as impedance. So 12 equal to 0.2 times of Z. It implies Z equal to 12 by 0.2, that is 120 by 2, that is 60 ohms. That is in case 1. Let's look at the case 2. The same circuit when connected to DC of 12 volts, there is certain current. So V is again 12 volts, but the current is here 0.4 amperes. 0.4 amperes. Then again I can use the same formula, V equal to IR. V by 0.4 is the resistance. So resistance is 12 by 4 by 10, that is 30 ohms. So there is a flow of current even when you are connected to the DC. That is possible only when there is no capacitor in the circuit. In 3 of the circuits there is capacitors. Imagine there is a resistor, there is a capacitor connected to a DC source. What happens when the current starts passing is, this capacitor stores the charge and it does not allow the charge to further flow in the circuit. Thus what happens is, we will be never able to complete the circuit and current will never flow in the circuit. So having a capacitor in the circuit is a deal breaker. Inductor and resistor are okay. Inductor opposes it, but induced EMF is being generated, but that's okay, that will at least continue the flow of the current in the circuit. That's how we have to solve the problem. Therefore, when it is in AC, it must have been LR circuit, never a capacitor is there in the circuit, because capacitor stops the flow of current in DC circuits, rather it stores the charge stores the energy rather than passing the current through it. That's it. Thank you for watching.